Okay, hi kids. Now we'll be going the continuation of the previous class. So till previous class, what we have done? We have done like work energy power and circular motion. So what are the basic things we learnt in work energy power? We have learned the definition. So why I will be writing this in every class is so that you will understand like what's there in the chapter exactly. And work done by all forces equals to change in kinetic energy, and then conservative forces, non-conservative forces. The examples of conservative forces are weight and spring force. Examples of non-conservative force is friction. So for conservative forces we will define potential energy. For gravity, for gravity system it is mgh. For spring it is half k x square, right? So how we will define that potential? In the first place, work done by conservative force is negative of change in potential energy. The same thing you can write it as, if you want to find the force, then it will be minus du by dr in r cap direction. The same thing if you want to write in rectangular coordinate system, it is minus dou u by dou x I cap plus dou u by dou y j cap plus dou u by dou z k cap, right? So thereafter you have seen about stable equilibrium, unstable equilibrium and neutral equilibrium. Stable equilibrium is potential energy is minimum case, unstable equilibrium potential energy is maximum. Then we started connecting these two, right, using potential energy. So that's like work done by all other forces equals to change in mechanical energy. If work done by other forces is 0 other than conservative, then mechanical energy will be conserved. Then we defined power. Power is rate of work done that turned out to be F bar dot V bar, and average power will be work done by time taken, right? Yes, so that's about a chapter work energy power. And sometimes what happens is, sometimes they'll be giving you, they'll be saying like force is in this direction and displacement is going to happen in this direction. So this one, it will turn out to be simple F bar dot dx bar. F bar dot dx bar integral will turn out to be f dx when force and displacement are in the same direction. So if you want to find total work done, it's like integration, right? Yeah, this is small work done. So total work done is integration of this, integration of this, integration of this. Now what does this say? It is area under f dx graph, right? F dx, it is area under f dx graph. Area under fx graph, right? So work done can be said as like area under fx graph, or work done will turn out to be change in kinetic energy. So area under fx graph gives you total work done or total change in kinetic energy. Okay, so then we learnt about circular motion. In circular motion, what is the major thing? When some particle is performing circular motion, when its speed is v, then there can be two kinds of accelerations. One is must and should, that is centripetal acceleration, which is v square by r, and the other kind of acceleration is tangential acceleration, which will be responsible for change in the speed. This is responsible for change in the direction, and we have defined theta, omega, alpha, which are similar to s, u and a. So this v will turn out to be omega square r, right? Because we got like v bar equal to omega bar cross r bar. Right. I have derived some other stuff. You just keep it in the notes because you will understand its importance in rotation chapter. So when it is in circular motion, you can just think of these two terms. Whenever some particle is performing circular motion, there must be some centripetal acceleration definitely, because it has to change the direction of velocity, and this is not needed but if it is there, then what will happen? Speed will change, right? Yeah, thereafter we went with vertical circular motion. If there is a string, what must be the massless string and bob, what must be the minimum velocity needed to be given at the bottommost point? It is root 5 GL. Then it will perform circular motion, right? Yes. Yeah, we'll go to the leftover questions. Okay, this question, this is from circular motion, right? Okay, we'll 8, 10. Okay, so this is one question which we have done in the very beginning using kinematics, but now we'll be doing using work energy power. Okay, a particle of mass m. Okay, so there is some particle of mass m and the force in the upward direction is 2 minus alpha z mg and weight is mg downwards, where z is the height from the ground. Where z is the height from the ground. What is the maximum height to which the particle rises? What is the maximum height to which the particle rises? What does it mean by maximum height? Speed is going to become 0 at maximum height. So what I will be doing, I will be going with work done by all forces equals to change in kinetic energy. Now work done by all forces, how many forces are there? 2 minus alpha z into mg, that is one force, and the other force, yeah, this force is in the upward direction, so I am taking positive way, this is negative, so minus mg. So for any small displacement y in the upward direction, this will be doing positive work. Yeah, z in the, after z, if it is traveling some small displacement dz, what is the work done during that small interval? The work done during that small interval is going to be this force into dz. This force is in the upward direction, displacement in the upward direction, so positive value into dz I have put. Now this is force is in the downward direction, displacement in the upward direction, so it is negative. Work done by upward force is force times displacement, work done by downward force is force times displacement times minus 1. So this is the small work done, but if you want to find total work done, you have to integrate. Total work done equals to change in kinetic energy. Final kinetic energy, where it is maximum height, so final kinetic energy is 0. Initially it was starting from rest, so initial kinetic energy also 0, right? So where to where we have to integrate? When z is 0, initial kinetic energy was 0. When maximum height, final kinetic energy will be 0. Now you need to integrate it and you need to substitute the limits. So when I integrate it, I will be getting 2 mg into dz. Dz integration is z. When you substitute the limits, you will be getting h minus alpha mg. Z dz integration is z square by 2. Z square is, when you substitute the limits, you will be getting h square minus mg. Dz integration is z. When you substitute the limits, you will be getting h equals to 0. Now this mg, you can take it to the right hand side, and you can take one, yeah, 2h minus h is h minus alpha h square by 2 equals to 0. So h I can take common, I will be getting 1 minus alpha h by 2 equals to 0. So from here you will be getting two roots. One is, when will change in kinetic energy be 0? That is when h is 0, yes, that is initial point, right? Or when this is 0. When this is 0, what is the root you will be getting? H equals to 2 by alpha. That is when h equals to 2 by alpha, again the kinetic energy is going to become 0. That is, initially the force is trying to pull it up, somewhere down the line the force will become less than mg, so it will be accelerating for some time and it will be deaccelerating and it will come to rest, right? So that's the maximum height. So what is that option? That option is B. So A is wrong, which we have already seen. Now velocity of the particle at h by 2. Again I will be going with total work done equal to change in kinetic energy. How to get the total work done? 2 minus alpha z into mg, this is the force, into dz, that is the small work done, minus mg dz, this is the work done by small work done by gravity, that equals to change in kinetic energy, that is final kinetic energy minus initial kinetic energy, which is 0. Now you need to integrate it from where to where, right? So when you integrate it only, you will be getting final kinetic energy minus initial kinetic energy. So 0 to h by 2, 0 to h by 2. So they are asking what is the speed at h by 2, right? So again, when I integrate it, I will be getting 2 mg dz, integration is z. So when you substitute the limits, you will be getting h by 2 minus alpha mg z dz, integration is z square by 2 z square. When you substitute the limits, you will be getting h square by 4 minus mg dz, integration is z. So when you substitute the limits, you will be getting h by 2 equals to half mv square. M. So 2 will go, 2 and 2 will go, yes, fine. So when you substitute the limits, what is the value of h? H value is 2 by alpha we got, g into 2 by alpha minus, or else I think I can substitute it in the next step. So this is gh minus gh by 2, so I will be getting gh minus alpha by 8 h square equals to half v square. G into h is 2 by alpha minus alpha by 8 into 4 by alpha square equals to half v square. Okay, so you will be getting 4 and this will go 2 2 is 4, 4 minus something is wrong, so there is g here also, yes, 1 alpha and 1 alpha will go, 1 alpha and 1 alpha will go, so you will be ending up with 2g by alpha minus g by 2 alpha equals to half v square. So this is 3g by 2 alpha equals to half v square. So v equals to root of 3g by alpha. Is that correct? No, something is wrong. 2 minus alpha z mg, okay, minus mg, so 2 mg h by 2 alpha mg by 2, okay, mg into h by 2 equals to half m v square, okay. So 2 and 2 will go, gh minus gh by 2 is gh by 2, gh minus gh by 2 is gh by 2, so this you will be getting h by 2 is 1 by alpha. So when it is 1 by alpha, so you will be getting here 2 minus 1 g by 2 alpha, so you will be getting v as root of g by alpha. So that's what we will be doing. Total work done equals to change in kinetic energy. The same thing we used to find the maximum height, the same thing we used to find what is the speed when the height is h by 2. Now we will be going for the last option. Last option is work done by F during the motion up to h by 2. Okay, that is this much, right? That is this much. So that is this much, which is, yeah, let me see what is this. This is gh minus g into h, h is 2 by alpha minus alpha g by 8 into h square is 4 by alpha square. So you will be getting 2g by alpha minus g by 2 alpha, that equals to 3g by 2 alpha, 3g by 2 alpha. That is the work done by only this force when till it is going to h by 2, 3 mg by 2 alpha. There is m. Okay, there is m. Right? Yeah. And going to the next question. Yeah, this question is not from this chapter, so I am not going to do it, but you can note it down like in which chapter you are going to do it, so that you can try it when that chapter comes. This is from center of mass chapter, center of mass or collisions. So you need to know what does it mean by coefficient of restitution to solve the question. So that's from other chapter. Yeah, this question, it is given in work energy power, but it must have been given in circular motion. A particle is acted upon by a constant force which is always perpendicular to the velocity. So if there is velocity and the acceleration is perpendicular to velocity, what we will call that acceleration as? We will call that acceleration as centripetal acceleration. So what will happen when that is the case? It will be performing circular motion. It will be performing circular motion. But is the velocity constant? No. Magnitude wise it will be constant, but direction wise it will be changing. Is the acceleration constant? No. Acceleration is always towards the center, right? So velocity is magnitude wise remaining same, but direction wise changing. So velocity is not constant because direction is changing. Acceleration is remaining constant in magnitude, but direction wise it is changing. So acceleration is also not constant. Kinetic energy, yes, kinetic energy remains constant because the force is perpendicular to the small displacement. Work done by that centripetal force is always 0. It moves in a circular path. So C and D are correct, right? So those are the leftover questions from work energy power. Going to the leftover questions from circular motion. Yeah, this question you can't exactly do it in this chapter. You can understand it much better in rotation or rigid body dynamics. And this question, this is also not from this chapter. This is from Newton's laws. Newton's laws must have been done for you. So you can do this question. If you want, you can try. So what will be happening here? So a circular disc with a groove along its diameter is placed horizontally. A block of mass 1 kg is placed as shown. The coefficient of friction between the block and all the surfaces is 2/5. The disc has an acceleration 25. The acceleration of the block with respect to the disc. Acceleration of block with respect to the disc. So what you can do is you can start observing from disc frame. When you start observing from disc frame, on this block there will be pseudo force, right? How much is that pseudo force? What is the mass? Mass is 1 kg. So the force is going to be 1 into 25, which will be 25 Newton. Pseudo force will be 25 Newton. Now apart from pseudo force, that's a horizontal disc, right? So what will happen? There will be mg downwards. So that mg I am putting it like this. mg is downwards, so I am putting it like into mg, right? Now apart from that, if mg is downwards, there will be some normal pushing it upwards, right? So that normal I am calling it as, again, magnitude wise mg, right? Magnitude wise mg. Now apart from this is mg, there is one normal here, right? One normal here. Now apart from that, what is going to happen? There will be normal from this side also. This side will be trying to push it, right? Sorry, there will be normal from this side because from ground frame it is trying to push it this direction, right? Now the other way of saying it is, in this frame when pseudo force is acting this way, it is not going this way. The meaning is there must be some normal in this direction also. So one normal is in the upward direction. Now if this is the horizontal plane, one normal is in the upward direction, but at the same time one normal is perpendicular to the groove, right? One normal is upward direction, one normal is perpendicular to the groove. Now this normal is going to be how much? For that I will be resolving this 25. So I will be resolving this 25 along, okay. I will be resolving all the forces along the groove and perpendicular to the groove. So this is perpendicular to the groove and this is along the groove. So this 25, when I resolve, this angle is theta. So this angle is theta. This is 90 minus theta. So 25 sin theta. 25 sin theta. Sin theta is 3/5. So which is 15. So this 25 component is going to be 15 in this direction and it is going to be 20 in this direction. Now apart from that, this normal from the groove will be in this direction. Now apart from that, mg will be there, mg will be into, and normal will be out, which is again mg. M is 1, so this is 10. Weight is 10, normal is also 10. Now there are two normals, right? One is in the upward direction, one is in this direction, right? Now there will be friction at both the places. There will be friction at the base, which is exerting the normal in the upward direction, and there will be friction at this surface also, right? It is trying to push the block this way, right? So there will be normal here, so friction will be in this direction. Now apart from that, this base is exerting mg in the upward direction, right? So there will be normal, in this direction, so there will be friction in this direction. There will be two places where you will be getting friction. One is because of the normal in this direction, one is because of the normal in this direction. So there will be two kinds of frictions. So how much will be the friction? So friction because of this normal will be mu into n, which is 2 by 5 into 10, which is 4. Mu into n, mu is 2 by 5 given, and that capital N is 10, so this is 4. So friction because of this normal is going to be 4. Now there is this normal, right? So how much is that normal? This normal is 15. So how much will be the friction there? 2 by 5 into 15, which is 6. So friction along this surface is going to be 6. Now what is the net force? Net force along the groove is 20 minus 10, which is 10. 10 equals to mass times of acceleration. So acceleration is 10. What we did here, we solved the question with respect to disk. So that is the acceleration with respect to disk. That's what they are asked. But if someone asks you what is the acceleration from ground frame, that is acceleration of the disk 25 plus acceleration with respect to disk 10. You need to add these two vectorically if someone asks you what is the acceleration with respect to ground, but they asked only acceleration with respect to disk, so that is 10, right? Yes, that's all about the leftover questions, and I think there is no need of notes much. If you want, you can refer the material, but most of the stuff were like just the equations only, and understanding potential energy and work done by all forces equal to change in kinetic energy. So that's the important thing in the chapter, right? So now that's all about the chapter. Now I'll be going with some questions from previous mains of work energy power, so that you can see like what will be the kind of questions they will be asking in the exam generally, so that you can prepare accordingly. No matter what is the exam you are writing, you need to solve previous year's questions, because you need to be aware of what will be the kind of questions they will be asking. And if someone doesn't have time to watch the lecture videos, then you can stop it here, because I have taken like everything needed for the every theory needed for solving the questions. Now this is extra. If you have time, you can solve these questions, or you can just stop it here and you can go to the other subjects and you can watch them. That's up to you. A boy is rolling a 0.5 kg ball on a frictionless floor with the speed 20. The ball gets deflected by an obstacle on the way. After deflection, it moves with 5% of its initial kinetic energy. So what was the initial kinetic energy? Initial kinetic energy is half m into v square. So that is 100. So 5% of initial kinetic energy is 0.05 times of 100, which is 5. Now if that much is the kinetic energy, what will be the speed? If this is the kinetic energy, what will be the speed? Half into m into final velocity square. So that is going to be v equals to root of 20. That lies between 20 lies between 16 and 25. So that root will lie between 4 and 5. So the answer is going to be option 2, right? A constant power delivering machine has towed a box which was initially at rest along a horizontal straight line. The distance moved by the box with the time t. Constant power is F into F bar dot V bar. They said this is constant, so let me call it as K. Now generally you will be taking force and displacement are in the same direction when they don't mention. It's like only one force is there, so it will be creating acceleration in the same direction and velocity in the same direction. So F into V, F is ma into V equals to K, some constant. Okay, so they are asking only proportionality, so this mass is constant, so I can say A into V is some other constant. A into V is some other constant K2. So A is dV by dt into V equals to K2 into K2. So V dV equals to K2 into T. Now I need to integrate it to get velocity as a function of time. This is dt. So when I integrate from 0, when it is 0, its speed is 0, it's at rest. After time t, its velocity is v. So when I integrate it, I will be getting v square by 2 equals to K2 into t. So v equals to some constant, some other constant K3 into root t you will get. So again v you can write it as ds by dt. ds by dt is some constant K3 into root t. So ds equals to K3 into root t dt. Now when you integrate it at t equals to 0, we will say position is 0. After time t, what is the displacement? S equals to some K3 into t power 3 by 2 by 3 by 2. Now this one I can call it as other constant K4. So displacement is proportional to t power 3 by 2. I think this kind of question we have already solved from the package, I guess, right? So this is the next question. As shown in the figure, a particle of mass 10 kg is placed at point A. When the particle is slightly displaced towards right, it starts moving and reaches a point B. The speed of the particle when it reaches B. So how many forces are there? Gravity and normal will be acting. Normal won't do any work. So work done by other forces are 0. So you can conserve mechanical energy. So what I will be doing, I will be taking this as potential. This potential energy reference is 0. So this potential energy is mgh, which is 10 g. H is 10. So which is potential energy is 1000. What is the kinetic energy? 0. Now when it reaches here, what is the potential energy? mgh, which is 500. So kinetic energy is going to be, total energy must be 1000, right? So if this is 500, then kinetic energy will be 5000. So what is, 500. So what is the speed? Half m into v square. So from here you will be getting v equals to 10. Yes, v equals to 10, right? So conservation of mechanical energy we are doing because work done by the only other force normal is 0. A ball of mass 4 kg moving with a velocity 10 meters per second collides with a spring of length 8 meters. So there is a spring whose natural length is 8 meter. There is a block which is coming with speed 4, which is coming with speed 10. There is a block of mass 4 kg which is coming with a speed 10 meters per second. It is colliding, and what will happen after colliding? It will try to go this way. It will be compressing the spring, but after some time it will stop. Why it will stop is the force. The spring force is opposing, right? Opposing, so this speed will reduce. The other way of saying it is this kinetic energy will be getting converted into potential energy of the spring. So let me draw the situation where it will be kinetic energy is 0. Let me say the spring got compressed till here and the speed is 0. Now let me say this compression is x. Then what are the only forces? The only forces are conservative forces. So I can say total mechanical energy will be conserved. What is the initial potential energy? Initial potential energy is 0. Initial kinetic energy is half into m into v square, which is 200. What is the final potential energy? Final potential energy is half kx square. What is the final kinetic energy? Final kinetic energy is 0. So initial mechanical energy equals to final mechanical energy. So initial mechanical energy is 200 equals to final mechanical energy half into k. K is 100. So that is 50 x square. So x equals to 2. This x equals to 2. So what is going to be this length? This length is 6. I have taken this as x, but what they are saying, they are asking what the length of the compressed spring. They are asking this. The length of the compressed spring is 6. Yes, the length of the compressed spring is 6. Two solids A and B of mass 1 kg and 2 kg respectively are moving with equal linear momentum. The ratio of their kinetic energies you need to find. So momentum will be given by mv kinetic energy will be given by half ma square magnitude wise, right? So generally what we do is we'll write the same thing as half, we'll multiply and divide with m, so we will get m square v square by m, so that is p square, momentum square by 2m. So sometimes we write kinetic energy as p square by 2m, so that we can calculate it much quickly. Kinetic energy equals to p square by 2m we will write. Now let us write the same thing because they are saying equal linear momentum, right? So kinetic energy of first particle k1 by k2 you need to find, that is p square by 2m1 by p square by 2m2, because they said momentum is same. So when you do this calculation, it will turn out to be m2 by m1. m2 by m1 is 2 by 1. So answer is 2 by 1, right? The potential energy of a diatomic molecule is a function dependent on r, equilibrium distance. So they are asking when it will be in equilibrium. So the meaning is force has to be 0. How you will be finding the force? Force will be given by minus du by dr in r cap. So magnitude wise it is like minus du by dr, right? So magnitude wise force is going to be how much? Minus du by dr. Okay, yeah. So minus du by dr is going to be how much? Or else force has to be 0, right? So I don't have to do this much, confuse with this much. Equilibrium, so that is force has to be 0, that is du by dr has to be 0. Now du by dr is going to be how much? U equals to alpha by r power 10 minus beta by r power 5 minus 3. So du by dr is going to be how much? Now this differentiation is minus 10 alpha by r power 11 minus this differentiation is minus 5 beta by r power 6. This differentiation is 0, right? Now this has to be 0. This has to be 0. When will this be 0? I can take r power 6 common, so then I will be getting minus 10 alpha by r power 5 plus 5 beta equals to 0. So from there I will be getting 5 beta. Yeah, this root need not be calculated because that is infinity. So when you go with the other root, 5 beta equals to 10 alpha by r power 5. So r power 5 is 2 alpha by beta. R power 5 is 2 alpha by beta. So r is 2 alpha by beta whole power 1 by 5. Whole power 1 by 5. So it is whole power 1 by 5. So A is 1. A is 1. 7th one. Yes. Going to the next question. Two particles having masses 4 gram and 6 gram are moving with equal kinetic energies. The ratio of their magnitudes of linear momentum. Just now we have seen kinetic energy. Sometimes we will write as p square by 2m for easy way. So they said equal kinetic energies. So p1 square by 2m1, that is the kinetic energy of the first particle, equals to p2 square by 2m2, that is the kinetic energy of the second particle. This 2 and this 2 will go, ratio of magnitudes of their linear momentum. So p1 by p2 whole square. When you bring this p2 here, you will be getting m1 by m2. So p1 by p2 equals to square root of m1 by m2, that is square root of 4 by 16, which is 1 by 2. 1 by 2. So 1 is to 2, right? 8 to 1, 1 is to 2. Yes. Yeah, you can look at the question. A small block starts slipping down from point B on an inclined plane AB, which is make an angle theta with the horizontal section. BC is smooth. This is smooth. And the remaining section is rough with a coefficient of friction mu. Remaining is rough with a coefficient of friction mu. It is found that the block comes to rest as it reaches the bottom point. So from here to here it will accelerate, from here to here it will decelerate, and it will come to rest. So initial speed is 0 and final speed is also 0. Then you need to find yeah, and they said BC is 2 times of AC. So let me say AC length is L, AC length is L, then BC length is 2 times of L, 2 times of L. The coefficient of friction is given by K tan theta. What is the value of K, right? So what are the forces from here to here? Gravity is there, but friction is there from here to here, and normal is always there. Normal will always do zero work because displacement is in this direction, normal is in this direction. Normal and displacement are perpendicular to each other. So work done by all forces equal to change in kinetic energy. I will go with work done by all forces equals to change in kinetic energy. Initial kinetic energy is, final kinetic energy is 0 and initial kinetic energy is 0, right? So work done by all forces. Work done by normal is 0. Work done by normal is 0. And now work done by gravity. Work done by gravity is going to be how much? Mg sin theta into this distance, which is Mg sin theta into 3L. Either we can find a displacement component along force direction or force component along the displacement direction, right? Now I did force component along the displacement direction. We have seen such example, right? Mg sin theta will do work, Mg cos theta won't do work. Mg sin theta into 3L, that is positive work because displacement is in this direction. Now what about friction? Friction is in the opposite direction, so it will do negative work. That is how much? Mu Mg cos theta is the friction into this much is the only distance, right? Friction is available only in this much distance into L. So this entire thing is 0. Now from there what you will be getting? You need to get the value of mu. Mg will go, so you will be getting L and L will go. So when you bring mu to the other side, you will be getting mu equals to 3 tan theta. Mu equals to 3 tan theta. So K value is 3. Yes, K value is 3. Now you can solve the same question using Newton's laws and kinematics, but that is going to be little lengthier than this method. If you want, you can check it. So you can understand the importance of work energy theorem from this particular question. I think this question makes you understand like work energy theorem principle is going to help you much better at some places. This kind of question we have seen just now. Constant power, so displacement versus time graph. When you do the displacement will be proportional to t power 3 by 2. T power 3 by 2 graph will be approximately like this. Okay, anyway, I will put the question so that you will understand. You can do after electrostatics. This question, ions and stuff, so this you can do only after electrostatics. Though it looks, a person pushes a box on a rough horizontal platform's surface. He applies a force of 200 Newton over a distance 15 meter. Thereafter he gets progressively tired and his applied force reduces linearly with the distance to 100 Newton. The total distance through which the box has been moved is 30 meters. What is the work done by the person during this moment? So there are two situations. Now what the better option you got is like you can try to plot force versus displacement graph. When you plot force versus displacement graph, what they said, force is constant, which is 200 for some time. 200 Newton constant force till the displacement is 15 meter. Now after that he got tired and it will be linearly reducing, his force will be linearly reducing and it will become 100 Newton. But what is the total displacement? Total displacement is 30, so this displacement is going to be 15. Now they are asking work done by the person. So work done by the person is integral f dx, right? So that is area under this graph. So what is the area under this part? What is the area of this part? That part is going to be 200 into 15 plus area under this part is 15 into 100 plus area under this part is 750. So that is going to be 3000 plus 2250. So that is 5250 joules, right? Yes. So the better option is plotting fx graph. whenever there are two situations, it's always better to plot a force versus displacement graph so that you can understand it much better what is happening. This question you can do after chapter heat. Again, this kind of question we have already solved. A body of mass 2 kg is driven by engine delivering constant power. Power is F bar dot P bar, which is simply F into V when the force and velocity are in the same direction. So that power is, they said, as 1 watt, and force is mass times of acceleration, so 2 into A into velocity is V. So from here I need to find what is the distance moved. So what I can write after some time, so you need to get time into the picture. So what I will be doing is I will be writing 1 by 2 equals to V, acceleration is dV by dt. Now V dV equals to dt by 2. I need to integrate so that I will get velocity as a function of time. At t equals to 0, it starts from rest, right? So at t equals to 0, velocity is 0. After some time t, velocity is V. So you will be ending up with V square by 2 equals to t by 2. So you will be ending up with V equals to root t. Now V equals to root t. Again V, what I can write as, I can write as ds by dt equals to root t. So ds equals to root t into dt. So when I integrate it at t equal to 0, position is 0. After some time t, displacement is s, position is s. So s equals to t power 3 by 2 by 3 by 2. So that is 2 by 3 times of, what are the limits? Limits are 9, right? T is 9 seconds. So when you substitute 9 power 3 by 2, 9 power 1 by 2 is 3. So 3 cube is 27. So 3 ones, 3 9s, 9 2s, 18. So answer is going to be 18 meters, right? Answer is going to be 18 meters. So what about the next question? This kind of question we have already seen. So I will be directly doing it quickly. We need to find force. Force is minus du by dr in r cap direction. It is equilibrium they are asking. So at equilibrium, force has to be 0. The meaning is this has to be 0. Now I will be finding u is given as minus a by r power 6 plus b by r power 12. So I need to find du by dr, and I need to see where it will become 0. Du by dr, so this will turn out to be 6a by r power 7 minus 12 b by r power 13. So from here I can take 1 by r power 7 common. I will be ending up with 6a minus 12b by r power 6. Now this has to be 0. If this has to be 0, this has to be 0. So you will be getting r power 6 equals to 12b by 6a, that is 2b by a. 2b by a. So 2b by a whole power 1 by 6, 1 by 6. So out of these two, one has to be correct. Now you need to find the potential energy. For that, what you need to do? You need to substitute r power 6 is 2b by a in potential energy, right? So potential energy is minus a by r power 6. R power 6 is 2b by a plus b by r power 6 is 2b by a whole square. So this will be minus a square by 2b, and this will be a square by 4b. So this is minus a square by 4b. Potential energy is minus a square by 4b. 17th one, yes, right? So this kind of question you have already seen. So I went directly. A particle slides down a frictionless track. Whenever you see frictionless, you can see, like, most of the times you can use conservation of mechanical energy starting from rest. So initially kinetic energy was 0 at point A. After reaching C, the particle continues to move freely in air as a projectile. When it reaches its highest point P, the kinetic energy of the particle, okay, they have given this distance as 1 meter. Fine, nice. Or else you should be knowing the angle, right? Now they have given this this potential energy is reference, so this potential energy is 0. So what is the initial potential energy? Initial potential energy is mgh, which is 1 into g into h is 2, so which is 20 joules. Initial kinetic energy is 0. Now here what is the potential energy? Here the potential energy is m into g into h, which is 10. So the kinetic energy has to be 10 because total energy has to be 20, right? Yes, that's all. The kinetic energy of the particle is 10. That's question number 8. Yes. So that's how the questions will be easy. Consider a force F equals to minus xi cap plus yj cap, work done by this force in moving a particle from 1, 0 to 0, 1. So small work done will be F bar dot dr bar, right? So if you want to find the total work done, you have to integrate it. So let me put a small work done in the first place. I will put the integration later. So F bar dot dr bar. F bar is how much? That much. Dr bar is how much? dxi cap plus dyj cap plus dz k cap. When I take the dot product of this and this, I will be getting minus x dx plus y dy. Minus x dx plus y dy. Now this is small work done. Now if I want to do total work done, I have to integrate it. From where to where? X is varying from 1 to 0 and y is varying from 0 to 1. Y is varying from 0 to 1. So what you will be getting? Total work done equals to, here you will be getting minus x square by 2. Minus x square by 2. Limits are from 1 to 0. So here you will be getting y square by 2, limits are from 0 to 1. So you will be ending up with 0 minus 1 by 2 plus 1 by 2 minus 0. So which will turn out to be 1, right? And it is going to be a conservative force because you can see this integration depends only on the initial and final limits. So it is going to be conservative force. This force is going to be conservative force. If you want, you can check by that method what I have shown you, right? Check whether this determinant is becoming 0 or not. A particle moves in one dimension from rest under the influence of force that varies with distance traveled as shown in the figure, the kinetic energy of the particle. Now what will area under the graph gives you? Area under the graph gives you work done. That is integral f dx, right? So that is work done. Work done, or this is nothing but same as this is work done. Work done gives you change in kinetic energy. Change in kinetic energy. That is, you need to find area under the graph. So what is the area of this part? Area of this part is going to be 2 into 2, 4. Area of this part is going to be 1 into 2, and this is going to be 1. Okay, this is going to be half into base into height, which is half. So this is 4 plus 2, 6, 6 plus half, 6.5, right? So area under the graph is going to be 6.5. So that will be the kinetic energy, or that will be the work done. This question you can do after center of mass. That will be much easier to do after center of mass. You can do now also, but you have to integrate it. But after center of mass, you feel like it's much easier question. For this, you need to know some other stuff like conservation of angular momentum. So that is after, you can do this after chapter rotation or rigid body dynamics. A block of mass m lying on a smooth horizontal surface is attached to a spring of spring constant k. The other end of spring is fixed as shown in the figure. The block is initially at rest and is in its equilibrium position. Now the block is being pulled. So initially it is at natural length because it is in equilibrium, they said, right? So spring force is 0. Now if the block is pulled with a constant force, what is the maximum speed? Now maximum speed, what does it mean by maximum speed? V is maximum, so that is dV by dt has to be 0. V is maximum, dV by dt has to be 0, that is net acceleration is 0, that is net force is 0. So the meaning is they are talking about some situation where the spring is expanded and where the applied force is F and spring force is also going to be F, that is k times of x. Now till now what will happen? Till now this force will be more than spring force, so it will be accelerating. After this, spring force will become more than the applied force, so it will be deaccelerating and the speed will become 0 and it will be performing oscillation. So maximum speed position is this position. Till here the force is more, so it will be accelerating. After this it will be deaccelerating, it will come to rest, it will come back, it will be performing oscillation. So kinetic energy will be maximum at this position, Okay, I will be going with total work done equal to change in kinetic energy. Total work done equal to change in kinetic energy. Work done by all forces equals to change in kinetic energy. Now what is the work done by applied force? Work done by applied force is positive, right? Because force is in this direction, displacement is in this direction. Displacement is how much? Displacement is F by k. So what is the work done by that force? F into F by k. Now what about spring force? This is going in this direction, so displacement is in this direction, but spring force is in this direction. So spring will be doing negative work. We have seen potential energy is half kx square, right? So work done by spring also going to be half kx square magnitude wise, but it is negative, right? Because displacement is in this direction, force is in this direction. So it is going to be minus half kx square equals to change in kinetic energy. Change in kinetic energy is final kinetic energy minus initial kinetic energy. Initial kinetic energy is 0, right? This x is F by k. So you will be getting F square by k minus half k into that x square is F square by k square. That equals to final kinetic energy half m v square, that is maximum kinetic energy. So from here you will be getting F square by 2k equals to half m v square. 2 and 2 will go, so you will be ending up with v equals to F by root of m into k. That is the speed at this position which is maximum. How much is that maximum speed? F by root of m into k. F by root of m into k. Okay, we will be going with the next question. The next question says a force acts on a 2 kg object so that its position is given as a function of time. What is the work done by this force in first 5 seconds? So this question you can do it two ways. You can find force like x, you know, right? X is 3t square plus 5. So I can find velocity by differentiating it. So I will be getting 60. I can find the acceleration by differentiating it. So I will be getting 6. So I know the force and I know, yeah, displacement. Yeah, that's hard. Yeah, I know force and I can find displacement and I can multiply force with displacement. But that's going to be a lengthy process because work done is same as kinetic energy, right? So they are asking work done. If you want to directly find work done, you need to do F into force is constant, so I can say like F into S directly, right? But that's going to be a lengthy process. I can say that same work done will be same as change in kinetic energy. Initial kinetic energy was how much? When t equals to 0, speed is 0. So initial kinetic energy is 0. So change in kinetic energy, work done equals to change in kinetic energy. Change in kinetic energy is final minus initial, and initial is anyway 0. So total work done will give us kinetic energy after 5 seconds, right? So what will be the kinetic energy after 5 seconds? What will be the velocity after 5 seconds? It will be 30. So what will be the kinetic energy? Half into m into v square. So that is going to be 900 joules. What is the work done? 900 joules. So instead of going with work done, we have deviated our path and we found change in kinetic energy because that is easy to calculate. A block of mass m is kept on platform which starts from rest with a constant acceleration g by 2 upward as shown in the figure, work done by normal reaction. So if you look at FBD, m, there will be its own weight mg and there will be normal. It is accelerating upward, so normal must be more. Now how to calculate normal? Normal minus mg equals to mass times of acceleration. Acceleration is g by 2. So from here you will be getting normal value as 3 mg by 2. 3 mg by 2. So work done by normal reaction is going to be how much? Normal is in this direction, displacement is in this direction. So I can simply write it as normal into displacement, right? So normal is 3 mg by 2. And what is the displacement? Displacement is half a t square. A is g by 2. So this is going to be 3 by 8 m g square t square. 3 by 8 m g square t square. Right? Now you can't find kinetic energy here and you can't say that is the answer, because here kinetic energy will be because of total work done because of two forces, that is normal and weight. They are specifically asking what is the work done by normal. So you can't use change in kinetic energy, because change in kinetic energy will give you total work done by all the forces. A particle which is experiencing a force undergoes a displacement. Force is constant. Force is constant. If force is constant, what I can say, work done is F bar dot S bar I can say. And displacement is given 4I cap. If the particle initially had kinetic energy 3 joules, what is the kinetic energy at the end? So work done equals to change in kinetic energy, right? So change in kinetic energy, final kinetic energy minus initial kinetic energy is 3 joules. What is the work done? Work done is dot product of these two. Dot product of these two will be 3 into 4, 12. Because J cap it is 0, right? So 12. So from here we will be getting final kinetic energy as 15. Right? Yeah, so these are some of the questions from previous mains work energy power chapter. In the next class, we will see some of the questions from either previous mains or NTA based. There will be some app called NTA Abhyas app, which is like for practicing mains level questions. So either we will see some of the practice questions from circular motion also in the next chapter, right? Thank you.